Good morning, afternoon, evening, from wherever you're watching. Welcome back once again to the Mickey Mouse class, a channel that is solely dedicated to demystifying mathematics and making our complex problems easy. All right, in our continuation of indices, today we look at indical equations leading to simultaneous equation. Before we looked at the laws of indices. If you have not watched it, you can check out the video on it. We looked at examples on indices. We solved various examples. Now today we'll be looking at indical equation leading to simultaneous equation. Let's take the first example. We could have something like this: 5 raised to the power 2x minus 26 into bracket 5 raised to the power of x plus 25 equals 0. A quadratic equation is an equation in which the highest power of the variable is 2. Now, let's simplify this. From here, this is 5 raised to the power of 2x. Let's break it down from the multiplication law of indices. For this 2 raised to the power x to come about, that means something was added. The powers were added. Now, this could be split into 5 raised to the power of x. The powers were multiplied, right now. Raised to the power of 2. I can split it because x times 2 is 2x. I didn't change anything. All I needed was to separate this x here. So this becomes 5 raised to the power x raised to the power of 2 minus. Why I did it is because I want to make it similar to what I have here, so that I can factor out this. I can replace it with a number. So this becomes minus 26, 5 raised to the power of x plus 25 equals 0. Now, this is very crucial. You now say let 5 raised to the power of x be equals to any number you like. Let's say a. Be equal to a. That means wherever I see 5 raised to the power of x, I put a. So I replace this by a. So this becomes a raised to the power of 2 minus 26a plus 25 equals 0. Now this has become a quadratic equation. There are various methods of solving the quadratic equation. Now let's use the factorization method. And in factorization method, what I will do is I'll look for two numbers such that that's the rule. When I multiply these two out first. Let's put it at the corner. 25 times a, that's 25a squared. Look for two numbers such that when I multiply them, I will get 25a squared. And when I add them together, I will get minus 26a. The two numbers are minus a and minus 25. So we replace this by it. So this becomes a squared minus a minus 25a plus 25 equals 0. Look at minus a times minus 25a will give you minus 25a squared. When you add them together, you get what is in the middle. Now, you factorize by grouping them. This to this. So this becomes what is common between these two is a. So this is a into bracket a minus 1. What's common between these two? 25. So that's minus 25 into bracket a minus 1 equals to 0, because minus 25 times minus 1 is plus 25. Now, a minus 1, a minus 1. So bring it out. So this becomes a minus 25 into bracket a minus 1 equals 0. Now, quadratic equation, why I call it quadratic equation? Because this equation has two answers. There are two solutions to it. Now, that means a minus 25 equals to 0, or a minus 1 equals to 0. When we solve this, that means a equals 25. That's a is equal to 25, or when this one comes here, when you solve it, a equals 1. So these are the two solutions to this quadratic equation. That means a is equal to 25 or 1. But remember, in this place, we said let 5 raised to the power of x be equal to a. So we are going to replace the value of a we got to this place, because this place is very, very crucial when you are solving indical equation. So this becomes, but we know that 5 raised to the power of x equals to a. And here our a is 25. So 5 raised to the power of x equals 25. Now let's split this 25 to have the same base with this 5 here. This becomes 5 raised to the power of x equals 5 raised to the power of 2. 25 is 5 raised to the power of 2. Now they have the same base. This will cancel out. So x equals 2. Now let's look at the second one. A is equal to 1. Now 5 raised to the power of x equals 1. And from our 0 index, anything raised to the power of 0 is 1. So I can replace this 1 as 5 raised to the power of 0. It has the same base as this. So 5, we cancel 5. So x equals 0. So the solution to this indical equation is, therefore, our x equals to 2 or x equals 0. So those are the two solutions to this indical equation. This is the first example. All right, let's take example 2. You have 3 raised to power 2x plus 1 plus 3 raised to power x plus 2 equals 12. Now the first thing, just like example 1, we have to split these powers here, x plus 2, split it using the multiplication law. This one can be split as 3 raised to power 2x times 3 raised to power of 1, because it was from this that this was gotten. Because when you have the same base, from the multiplication law, it says we should add the power 2x plus 1 from the law of indices. So we split it back to the form in which it came. Now plus, when we split this becomes 3 raised to the power of x times 3 raised to the power of 2 equals 12. The same way you split this first one, you split this. Now from here, this becomes, split this one further. So this becomes 3 into bracket x raised to the power of x into bracket raised to the power of 2. You split this one times 3 raised to the power of 1 plus 3 raised to the power of x times 3 raised to the power of 2 equals 12. Now from there, we have 3 raised to the power of x. Now let us represent this 3 raised to the power of x with anything. You can use b or anything. You say let 3 raised to the power of x be equals to b. So whenever we see 3 raised to the power of x, we put b. So this becomes b squared times 3 plus, this is b times 3 squared is 9 equals 12. Now 3 times b squared, that's 3b squared. B squared plus 9b equals 12. It becomes a quadratic equation. Now from here, let's bring this 12 here. You subtract 12 from both sides, so it becomes 3b squared plus 9b minus 12 equals 0. When you subtract 12 from both sides, now this is a quadratic equation. How do we do it? Let's factorize. This becomes minus, multiply this times this, keep the answer in one corner, minus 12 times 3b squared. That will be minus 36b squared. Now look for two factors such that when I multiply them, I will get minus 36b squared, and when I add them together, I will get plus 9b. That is the rule for factorizing. Now the two numbers I can have is 12 times 3. 12b times 3b. But not just 12b times 3b. 12b times minus 3b. Because when I add 12b and 3b together, I will get this. When I multiply 12b and minus 3b, I will get minus 36b. There are other factors, but they will not satisfy that condition. They will not satisfy that condition in that when I add them. For example, 12 minus 12b times 3b will give me this minus 36b. But when I add them, I will get negative 9b. So I cannot use it. There are other factors, there are other things that can 9 times 4 will give me 36. But there is no way I can add 9 and 4 to give me this. So this is the only factor that satisfies it. So I replace it. So this becomes 3b squared plus 12b minus 3b minus 12 equals 0. I factorize by grouping. What is common here? 3b. So I bring it out, 3b into brackets. This is b plus 4. What's common here? Minus 3 into brackets b plus 4 equals 0. So this becomes 3b minus 3 b plus 4 equals 0. Now let's find, that means 3b minus 3 equals 0, or b plus 4 equals 0. Let's solve this. So this becomes 3b equals to 3 and b is equals to 1 when you divide both sides by 3, and here b is equals to minus 4. So b is 1 and they are all minus 4. But that's not the end. We go back to where we represented b as, where we said let 3 raised to the power of x be b. So 3 raised to the power of x equals to b. See, but 3 raised to the power of x equals to b. And from here, when we solve the quadratic equation, we got b to be 1 and minus 4. Now, so 3 raised to the power of x equals to 1. 1 from the 0 index, anything raised to the power of 0 is 1. So we can as well replace this 1 as 3 raised to the power of 0. Now they have the same base, cancel out. So our x equals to 0. Now look at this. 3 raised to the power of x equals to minus 4. There is no solution that fits in. There is no way I can split 4 minus 4 to have a base of 3. So the answer is x is equals to 0. That's the answer for the second one. Alright, take the third example. We have 2 raised to the power of 2x plus 2 raised to the power of x plus 1 minus 8 equals 0. Now, the same thing, the way we have been solving the other indical equations, let us split this. This can be rewritten as 2 raised to the power of x raised to the power of 2 using the power law plus, let's split this one using the multiplication law, 2 raised to the power of x times 2 raised to the power of 1 minus 8 equals 0. Now, I have 2 raised to the power of x, 2 raised to the power of x. So, let's represent it with a letter. We say let 2 raised to the power of x be equals to p. So, anywhere I see 2 raised to the power of x, I replace it by p. So, this becomes p squared plus p times 2 raised to the power of 1 minus 8 equals 0. 2 raised to the power of 1 is 2. So, this is p squared plus 2p minus 8 equals 0. This becomes a quadratic equation. Now, how do we solve it? Like we have been doing, we use factorization method. The first thing, multiply these two terms. Minus 8 times p squared. You put the answer in one corner, minus 8p squared. Keep it. Now, look for two numbers such that when I multiply them together, I will have minus 8p, and when I add them together, I will have what is in the middle. The two numbers or the two factors are 4 and 2 and minus 2. So this becomes p squared, that's 4p and minus 2p. That's what satisfies that condition. When I multiply 4p times minus 2p, I will get minus 8p squared. And when I add them together, I will get what is in the middle. So this becomes p squared plus 4p minus 2p minus 8 equals 0. Now you factorize by grouping. So this becomes what is common between these two, p into brackets p plus 4. What's common between these two? Minus 2 into bracket p plus 4. equals 0. So I have p minus 2 and p plus 4. So this becomes p minus 2, p plus 4 equals 0. Therefore, p minus 2 equals to 0, or p plus 4 equals 0. So from here, p is equals to 2, add 2 to both sides, or p is equals to minus 4. So those are the two solutions to the two answers to the quadratic equation p squared plus 2p minus 8. So p is equals to 4, or p is equals to minus 2. Now we come back to where we replaced. Let 2 raised to the power of x be equals to p. But we know that 2 raised to the power of x equals to p. Now replace the solution set of p in this place. So this becomes 2 raised to the power of x equals to 2. Now 2 is the same thing as writing 2 raised to the power of 1. So they have the same base. Cancel out the base. So our x equals 1. Now the second answer to p is 2 raised to the power of x is equals to minus 4. Now there's no way, or there's no valid solution to this. So this one cannot be used because this is not a valid set. There's no way I can split minus 4 to have a base of 2. So this is not a valid solution. Therefore, our x is equals to 1. That is the value of x. I hope you have enjoyed today's lesson. If you have any question or anything that you do need me to explain further in indical equation, put it in the comment section. Before we go, our usual style, I'm going to write down some questions, the take-home fun for you to practice at home. Remember, mathematics is fun. Right, so like our usual style, the take-home fun. The first question, 4 raised to the power of x minus 16 equals 0. The second one is 4 raised to the power of x minus 32 equals 0. The third one, 2 raised to the power of 2x plus 1 minus 5 into bracket 2 raised to the power of x plus 2 equals 0. And the last one, 25 raised to the power of x minus 5 raised to the power of x minus 20 equals 0. Okay, let me know the answers in the comment section. Remember, mathematics is fun. I hope you have enjoyed today's class. See you in the next lesson. Shalom.